growth and decay. Okay, so with growth and decay, you're going to use this formula. So you've got, it's on your paper, a times 1 plus or minus r, and we're going to raise that to the t power, right? Okay, now a is going to be your initial, r is going to be your rate, and t is going to be your time or number of years. Okay, now this plus minus nonsense. If it is a plus, it's going to be growth. If it's a minus, it's going to be decay. Okay, so on this first one, it says you deposit $3,000 into an account that pays 6% interest annually. Okay, write an exponential model for the value of account Y in dollars after t years. So we're going to plug in 3,000 in for A, and 1 plus, what's my interest rate converted into a decimal? 0.06. So we're going to say plus 0.06, and we're going to raise it to the t power. Now on part 2, it says estimate the value of after 5 years. So all we're going to do is take 5 and plug it in for t. So we're going to say 3,000, 1 plus 0.06 raised to the 5th power. We're going to go into our handy dandy calculator. We're going to say 3,000, oh, that's 30,000. 3,000 parentheses 1 plus 0.06, and we're going to raise it to the 5th power. What do we get? 4,014.68. 4,014.68. If you didn't get that, look at how you typed it into the calculator versus how I typed it into the calculator. So population, okay, so this is also going to be a growth thing. So it says the student enrollment of a high school was at 1,350 in 2008 and increases by 9.7% each year. Write a model given the enrollment E of the high school T after 2008. So we're going to use that growth equation. Okay, so we're going to say 1,350 times 1 plus my rate, which I would convert into a decimal, which is 0.0975. 0.0975. And I'm going to raise that to the t power. Also, just so you know, there's a flash flood one. Okay. Okay. So then it says predict the student enrollment for 2012. Now we went from 2008 to 2012. How many years is that? 4 years, right? Okay, so what we're going to do is we're going to take 4 and we're going to plug it in for t. So we're going to do 1,350 times 1 plus 0.0975, and we're going to raise that to the 4th power. So when we plug that into our calculator, we're going to get 1,350 parentheses 1 plus 0.0975 close parentheses raised to the 4th power. That's going to be 1958.6. Now, you can't have half a person, so we're going to include them as a whole person. So this is going to be 1959 students. Okay? Girl. No. Okay, so, yes. We use this when we predict student enrollment for the fall, and it actually affects us hiring teachers. Okay, so the number of students that we have impacts the number of teachers we can hire. So if our enrollment numbers are low, sometimes we have to let teachers go. Okay, so this really comes in handy when we're trying to predict what our student enrollment will be for the fall. Okay, so registration is super important. Here's my little plug. Okay, let's talk about depreciation. That means that we're going to have decay happen. You know how you always were told if you buy a brand new car, the moment you drive it off the lot, it loses 50% of its value? Yeah. So here, this is kind of the same process. Once you buy this new ATV car, I don't know what ATV is. Huh? Yeah, thought so. I was like, it's like a dune buggy. No, it's not. It's a 4-wheeler. You're right. Okay, the value of the ATV decreases by 10% each year. So we're going to write an exponential model for this. So this is going to be decay, so it's going to be 1 minus r, right? So we're going to take 800 and multiply it by 1 minus, what's our r? 0.1. And we're going to raise it to the t power. Now in part 2 it says estimate the value after 5 years. So we're going to plug in 5 into our equation. So when I do that, I'm going to get 800 times 1 minus 0.1, and we're going to raise it to the 5th power. I got 472.39. Yes, hola. Okay, so you buy a car for $22,500 and the value of the car decreases by 25%. So this is telling me that it's going to be decay. Okay, we also know that this rate is going to be 0.25, right? So when I write this, it's going to be 22,500 times 1 minus 0.25 raised to the t. Decay versus growth? Because it said decreases. Yep. Yep. Okay. What is the value of the car after 3 years? So we're going to plug in. We're going to be like, hey, we're going to say to the 3rd power, right?
What? Say something.
No? So then when I plug this into my calculator, I'm going to get 22,500. Ooh, I can't type. 1 minus 0.25. We're going to raise it to the 3rd power. What do I get? $9,492.19. Yeah? So, like, that really sucks, y'all. Like, $22,500 and then, like, in 3 years, it's only worth $9,000. Like, that makes my heart hurt just a little. Okay?